but roughly speaking, uh, the training involves like you give it a bunch of text. You have like a corpus of like text, and then when you're training it, you're like having it like play this game of like fill in the blank. And so you'll like maybe give it a sentence and you'll remove certain parts of the sentence. You'll try to have it predict what should be in that sentence, and what it's giving as output are probability distributions over it outputs a probability distribution over the possible they call them tokens. They're basically just words or well they're words and they're like some characters in there or something, but it outputs a probability distribution over basically what should go there and what should go in the blank or like what should go next. And then to actually generate text.
Just a
Um,
second, Jefferson, I'm trying to understand you. You're talking about some kind of guessing words game, yeah? You give a sentence which is incomplete, have missing words, and ChatGPT fills it up, yeah?
so this happens in the training process, and then in the once it's so like right now, once it's been trained, uh, in order to generate new text. So like say you give it a prompt and as input, what it'll do is for the next character or word or however they define like these tokens, it samples from like basically it's a conditional distribution given the prompt or like given the sentence so far, uh it samples from some like probability it samples from its like fitted conditional distribution of what the next word should be. And
Looks
then
to me like some kind of Bayesian model, or
yeah.
maybe even regression model, Bayesian model,
Yeah,
something like this, yeah?
yeah. So like in natural language processing, there were these so-called n-gram models. So those are like models where it's you you can it you kind of learn a probability distribution given the previous n words.
Yeah, yeah, but
The
it doesn't
distribution
look
of
to
the next
me
word.
like generative AI. It looks, or even reinforcement learning, looks
Yeah, so
like
the
Bayesian correlation, yeah.
yeah, the reinforcement learning part comes in when they then try to so the training doesn't end with just like you're playing this word game. So they also want it. So if you just play this word game, I think what people have seen has happened is that I mean you can train it up, you can have it generate text, but the text will like be obvious, it'll be kind of garbage. Um, so to actually make it so that it sounds like a person, they need to do some tuning afterwards, additional training. So the additional training, that's where the reinforcement learning comes in.
And where the generative AI, what is the role of a generative AI, if you know?
Generative AI just refers, it's kind of like a broad like catchphrase to include things like ChatGPT or like these image generation things, just like any sort of thing where you're like generating stuff, you
No,
can
no, no,
call it.
Jefferson, my understanding, roughly speaking, maybe I'm wrong, the generative AI is the procedure where you have some process for developing something, and which is roughly speaking forward Kolmogorov equations. Then they go to the end and go apply, roughly speaking, backward Kolmogorov equation, and they reproduced the process that it could be, and they
Uh,
especially
yeah.
appreciate the situation when it eventually comes to your initial state.
Yeah, so I think what you're describing is the diffusion models. So
Oh, it's a diffusion model.
that's a
Okay.
particular kind of generative, quote unquote, generative AI model. But as I understand it, things like ChatGPT or things that are like generating text are also included.
And what is, again, what is then in your, can you please just repeat what is generative? Because I
Uh,
saw the diffusion model, generative AI, the same thing.
no, diffusion models are a subset. a strict
Mm-hmm.
subset of what's considered generative AI.
And
Things
what
like
is generative
ChatGPT.
AI?
Let me see if I can find an actual definition. This kind of a buzzword sort of thing. I'm not sure if it's well defined. Okay, so looking at Wikipedia, for instance, it says it's generative AI is a subset of artificial intelligence that uses generative models to produce text, images, videos, or other forms of data. So something like ChatGPT is considered a generative model, I think, because you can use it to like generate text. So it's like
Yeah,
you're
I can simplify this definition. Generative AI is generative AI.
yeah, yeah. As with a lot of buzzword type things, it's of that nature.
The question, do we have an example of generative AI which is not diffusion?
Yeah, ChatGPT. ChatGPT is it's a kind of a transform it's called a transformer model. So ChatGPT is not a diffusion model.
Yeah, but my understanding again, what is generative um, is that it's not necessary to have diffusion model. You may have just Markov chain model, and then you inverse Markov chain
Hmm.
because this is the role of forward and backward Kolmogorov equations. So again, my understanding that they basically somehow create a model of the process, and then which basically leads to the end state.
Yeah, yeah. So for a diffusion model, I think the idea there is to you want to try to like sample from like the space of images or something, or like the space of images that contain cats or something. So what's done there is like it's so the idea comes from like these sort of encoder. There are these kind of like models where that involve like an encoder and a decoder. So like the forward process that you're describing is like you start with an image and then you basically add noise to it via like an
Mhm.
Ornstein-Limbeck process or something, or some like
Yes, and after the noise, you make several transformations and goes to some picture
yes,
of
well, no.
pixels
So
that is
so like you're
readable.
so like when you're training basically this kind of architecture that involves taking an image and you want to corrupt it to something like white noise. So
Hmm.
that's the encoder. So you're like encoding an image as white noise. And then there's like a decoder portion where you're taking white noise and like decoding it to like some image. And so when you're training this thing, it's like you're introducing like almost like an information bottleneck kind of thing. So it's like um, so you train the model so that if you give it an image and it passes it through the encoder and then back out the decoder, your measure of goodness, how good you're doing, is like you're whether you get it as output, whether that looks like a reasonable picture. And then when you're actually generating stuff, what you do is you just have the decoder part. So
Hmm.
you just like you sample some white noise and then you have it decode. And there are like conditional versions of this where where you can so the kinds of things where you can like tell it, oh, generate me a picture of something something. That's kind of a condition. There's a conditional version of this. Um, as well.
So is it true then the generative AI also includes some reinforcement learning? Because
Um,
uh, when you create the image that the system tells whether it's good or bad, or somebody, the
yeah, so
critic
it could have,
says,
yeah, so reinforcement learning could be involved in the sense that So I think like for diffusion models, I think people have used it to like because it's got very kind of a control sort of flavor to it, and you're like, yeah, at least implicitly trying to generate things that are quote unquote good. Um, and so I think people have used it to like generate like in like some kind of like path planning applications or things where instead of generating an image, you can generate like a path. And it's like you're trying to sample from you're trying to learn and sample from the distribution of like good like robot paths or something.
Yeah, yeah. I spoke to some people in robotics who do the generative AI. What they do, they basically use backward induction, whatever, for the process, and that leads to the current state. And then they basically count, and they consider this a success. And then they count the total number of successes and the number of particular moves that are successful. So, for example, you are in some state in point A and you want to reach the point B by doing random walk, but you don't know which kind of control to use. I call random walk what you call noise in this case. And so what you do, you basically go to the endpoint and do backward forward moves or backward moves, and then counts how much time you aim to the same point. And once you count how many times you come to the same point, you also count what would be the move at this point. And then based on the majority vote, you basically, or some maybe other algorithm, they decide which action is optimal, whatever.
Mm.
This is something like this.
Yeah,
They explained to me that's what they're doing.
yeah, yeah,
Yeah, it's like more looks to me more artificial than intelligence, but
yeah, yeah.
okay. But what in this context is foundational model? I can explain to you why I'm asking the question, but this explanation will be understandable mostly to Pavlov. Uh, so basically, there is a conference in that I will go, and it consists of several days. And one day is on artificial intelligence in biology. And I looked at the program of the artificial intelligence in biology. It's a tutorial day. It's all the tutorials on foundational models, nothing else. So to my understanding, the foundational models, they basically, you have some physical, biological, natural, or chemistry project process, and you basically need to convert it to some kind of a neural net. Like in language. In language, you have only words,
Yeah.
but eventually they should be converted to neural net. And this is basically the first thing is to create this kind of conversion that people basically, for example, they can write chemical formulas, and based on this chemical formula, the system will understand much more. And second, my understanding to assign also new natural neural networks to basically AI, but which also includes that's what my understanding of foundational model is. It right or it's wrong?
So I think foundation models, they're kind of more, it's certainly kind of broader than just like biological applications.
No, no, no. I'm talking about foundational models for biological applications. This
Okay.
is this is the name of the tutorial. That's the reason I'm
Yeah.
talking about biological applications. Yeah.
Yeah. So I think so I was just looking around now for like if there's a definition anywhere of like what a foundation model is. So it looks like on Wikipedia they just say it's a machine learning model that's trained on vast data sets so that it can be applied across a wide range of use cases. So things like these, like ChatGPT is like what's called a large language model. And so it's a particular, at bottom, it's just a particular kind of neural network architecture that it's not trained specifically for like biology or like solving math problems or helping you with your computer coding or something. But it's trained in a way that it's like pretty good at all of these things. But you can then take a foundation model and like fine tune it to be actually even better at like helping you be a coding assistant or something. So that's, yeah, foundation model it's in the sense that it can serve as a foundation for like now you want something that is like ChatGPT, but it can help you solve math problems or something. You can kind of fine tune it so that it's good at those specific things, but kind of as is, it's good at a broad range of things.
Could you please remind me what PyTorch is doing?
PyTorch is it's a way in which you can implement neural network models. So they have like packages where you can so there are certain kinds of like building blocks of neural networks that are pretty standard. So they implement those things, and it helps you build the overall neural network model, and there are like standard ways to train these things, and they've also implemented these things.
But for example, if we want to talk about foundational models, is some kind of language type of PyTorch is a part of it, or it's totally different?
No, you can talk about it. So like something like PyTorch is a way in which you can implement a foundation model. You can talk about foundation models without reference to, it's kind of like talking about what programming language do you want to implement.
Exactly. It looks like it's a high-level language for neural nets.
Yeah, PyTorch. Yeah.
Yes.
Yeah, right.
Yeah. So that means that, for example, my question is whether neural net or topology of a neural net is a part of the foundation model, or foundation model is totally different. For example, if we go to linguistics, for example, yeah, then one way to do is linguistic is transform language to sounds, and then your letters and whatever disappears, and you have some kind of Fourier transforms and signals and so on, which you can feed into the neural net, because it's not clear how to feed, at least to me, not clear how to feed alphabet into the neural net.
I mean, in a sense, that's kind of what it's kind of what they do.
Yeah, and my question is, this foundational model is just translators of the object we're working in. For example, in ChatGPT, we're working with words. So whether it's translation of words into objects that go to neural nets, or foundation model also includes neural nets. That's my question.
So foundation models, I think it includes neural nets in the sense that a neural net is a way in which you can implement a foundation model.
Okay.
Yeah.
Because we discussed with Paulo many times and other people that if you have such and such biological problem, that could be some such and such neural nets. And my question whether this topic belongs to the area of foundation models or not.
There is a comment. Neural network is
Please speak closer to the microphone.
Yes, neural network is the approximation of solution for foundational model. For example, in biology, of chemistry, if you have some chemical equations, for example, you obtain, if you want to describe a chemical process in time, you will obtain a so-called reaction diffusion equations. As usual, with nonlinear interaction functions. This is the foundation model, for example, but to solve these equations, you need you cannot solve them exactly because they are nonlinear. So you can use some numerical methods. The classical ones are very slow, as Ilya Waxer say, etc. So we need to use some approximations that can give you a solution on one hand which is sufficiently close to the original one, and on another hand that you can compute rather quick. And one of the novel methods is the so-called deep Galerkin methods. In this method, you use besides the classical solutions of the projections of the initial problem to ordinary system of ordinary differential equations. Besides this, you obtain some parametric optimization problem, which solution is the neural network. The specific of this approach is that in each iteration you do not need to solve the problem, approximation problem at once. If you use deep Galerkin methods via so-called physical informed neural networks, you need to count only one part of this neural network because some previous parameters are already computed. PyTorch is the extended version of NumPy framework, and it uses to simply compute the particles of neural network, activation functions, some matrices. It contains some algorithms for optimizations to search the parameters. For example, in matrices which the superposition of matrices and some functions is a neural network, for example, n-layers, etc. And this is, if you want to read a good presentation on this, is contained in the Berkeley course on deep reinforcement learning. They have some slides in the current course 2025. It contains at the Berkeley University course on deep reinforcement learning. And there is a lecture especially on PyTorch, and they have a very good and short explanations why and how it is used in computing of neural networks and related problems, and how it is used in reinforcement learning.
Pavlo, do these lectures, do they mention deep Galerkin methods?
No, they consider reinforcement learning methods or reinforcement learning. No, this is the reinforcement learning course, and it's connected to the models. No, to the situations where we mainly do not know the foundation model. They, if we follow to the papers, well known by DeepMind specialists, after like Tom David Silver, as I remember, Sutton, rewards are enough. They called that they give a hypothesis that to construct a sufficient artificial intelligence, we need to construct a partially observable Markov decision process with known state space, action space, rewards, but we possibly unknown transition probabilities. And it is theoretically possible by using versions or variations of policy and value iteration methods. No, theoretically. No, in our terms, this is the version of adaptive control problems. And therefore, there is two kind of tasks. Reinforcement learning algorithms that are grounded or based on partially observable Markov decision processes. They, in these problems, we do mainly. In these problems, we mainly do not know the foundation problem, or if we know this problem, we cannot solve it. For example, it's very difficult, or it has a lot of states, etc., and we cannot do this.
This is the case in biology.
Yes,
we know the model, but the dimension is huge.
Difficult to compute it, but such algorithms are in such situations. For example, a lot of them I saw such situations in Jefferson slides and papers when they consider, for example, some infiltration problem, some problem with asset allocations, searching problems. They make a foundation model, but in that situation, when it is rather difficult or impossible to solve them, as I understood, he used reinforcement